So, we are in the middle of the discussion on the database organizations. What I said on the last class, that there are 4 types of database organization: the flat file approach, the hierarchical, network organization, and the relational organization. The flat file approach is basically does not follow any particular structure, but it is you can assume it is a simple file without any interconnection between files. Only thing, there are no repeating groups. Fine. Then the hierarchical is like a tree structure, the usual parent child kind of structure, and advantage is if the query is from parent to the child. Alright, suppose student to the subject, then you have to answer queries like what are the subjects taken by a given student, what are the grades obtained by him, easy to answer. But the reverse ones, for example, from subject to student, who are the students who have taken a given subject, will be difficult to answer. Network on the other side is both ways, parent to child as well as child to parent, in the sense that 2 sets of record are on the same level and they are connected through link nodes which can have additional information, and we can, if the access paths or network connections are already established, then you can answer those kind of queries. This we have discussed. The relational structure, the database organization, is a totally different kind of organization, right. Here whenever you are adding, let us say a student has taken 3 more subjects, all right. In terms of hierarchical or relational structure, it means actually putting an access path or a pointer, you see, setting an access path or a pointer from the student record to the 3 subject record. This is what happens in hierarchical or network structure. So, you can see that every add, delete, modify is a cumbersome process in hierarchical or network structure, because it requires a change in the database organization. The relational database organization on the other side purely depends on algebra, right, a special kind of algebra which is called relational algebra, in short RA. Fine. So, here the basic idea of relational structure is that we have a tables, we have the tables which are usually depicted as a grid of rows, usually called tuples, right, and columns which are called attributes. A set of tables or rows represent unique records entities and the columns are representing the attributes. Links between tables can be established at any time algebraically, that is what is known as relational algebra, provided the tables have a field in common. You must have at least one field in common, sometimes more than a field in common, so that you can carry out the relational algebra and provide the answer to the queries. The relationships are represented by common data values in different relations. We will explain what exactly is meant by that. Suppose you have the relation between student and subject. Say you have a student file having the student records, you have another file called the subject file having the subject record. But how do you know that which student has taken which subject? See, what exactly I am trying to say is this, that we have a student record. We have a subject record. So, from the student record we get certain student roll numbers, names, etc. From subject number record we have some subject name, roll number, etc. But how are they related? Which student has taken which subject? In hierarchical relational structure, you have the, say, let us take some tuples as well. Say, we have some students and we have some subject details, right. Now, the question is, say these are like STID, this is ST name, this is ST hall, this is subject ID, this is subject name, this is LTP, lecture tutorial projects. Now, what is a tuple? This student record I have taken 3 tuples. So, this is the concept of tuple T1, T2, T3. How many tuples in student record? 3 I have taken. You can also consider 4th tuple, say roll number 22. Right. So, you can, I have taken 4 tuples here and 3 subject tuples. Now, in network structure, what you have to do, suppose A Roy has taken all the 3 subjects, then you have to define a pointer to each of these 3 subjects, and in between define a link node where you can probably keep the grade. In relational algebra, what you need to do, you have to establish it by taking a relationship table as well. So, how to get the relationship table? Usually through by considering the primary keys of both the tables, alright. So, we have to have a third table, let us call it ST sub. See, what is in a name? You can even call it takes, student takes subject, alright. You can call it ST sub. I mean, it is just a name. Please remember that student takes subject. You know, it's like easy to hear. So, we may even name the relationship as takes, but that takes is nothing but a name. You can as well call it ST sub. So, you can have student ID and subject ID and any field which is a property of both. For example, grade is a property of both. Okay. So, we can now tell me if this is the student, this is subject, then how many tuples ST sub can have? The upper limit. The upper limit of the number of tuples of ST sub would be 12. Why 12? Because assuming all the 4 students have taken all the 3 subjects. Is it clear? So, A Roy SAD, A Roy OS, A Roy EU1, S Das SAD, etc. Now, usually it does not happen. Usually it does not happen, and we may have less number of tuples in ST sub. Is it clear? Less number of tuples in ST sub. So, at least some few tuples, let me write. Right. So, I have taken a few tuples of only 5 I have taken. See, interesting question will be now that who are the students who have all got A grade in a given subject? Basically, what are the names of the students? What are the names of the student? Alright, suppose you have a query, what are the names of the students who have got A grade or who have got A grade in a subject? So, you see the answer cannot be given from one table, you require more than one table, alright. So, whenever you want to do that, you do what is known as a join operation. You join the 2 tables. Right. Say for example, who are the students of a particular hostel, say RK, who have got A grade? You see, I require to give the answer from 2 tables. Sometimes you may have to join all the 3 tables, right. So, there are 3 fundamental processes, we will discuss them later: selection, projection and join. Usually and some others as well. So, using these 3 fundamental processes, selection, projection and join, usually the queries can be answered, alright. So, we will take up SQL later on. Let us, before we come to that, let us see some comparison. This is a comparison of hierarchical network. I have probably said all these beforehand. In hierarchical or network structure, the connection and relationships are in the data structure with the help of connections and access paths, alright. The relational structure is flexible and useful for ad hoc queries. Complex DDL or DML are not required. We need not set up the access paths. For predefined relationships, access paths are more efficient than general table operations. So, these are known as the relational algebraic operations known as general table operations. I said at least 3 processes: projection, selection and join. And so, for predefined queries, hierarchical network structures are competitive. means as good as relational, maybe even better, right. But unfortunately the world has moved on. See what has happened in today's world, we cannot depend on what queries will be asked, right. The time has come when you have to make an open kind of a system where any kind of queries can be answered, right. We should be prepared, because as the businesses are expanding and as data processing or information systems have become more and more complex, and see, you have to also understand that efficiencies can no more be generated from a single system. A single system, the days of efficiently running a single system is over. Increasingly we have to have combined systems. For example, not optimize production alone, optimize production and marketing together, right. So, say that is why we today increasingly hear things like enterprise resource planning, ERP, supply chain management, SCM, including IT, the IT advantage of doing business in a new way, globalization of business. We keep on hearing these newer terms, which basically draws the total quality management, basically draws from integrating several applications. So, when you are integrating several applications, today's queries are also going to be across platform. Across platform. If the marketing decides not to sell too much this week or this period, what will be the impact of that in production decisions? So, you see, this is not a straightforward query which you can give from a single table or a single set of data. You require multiple data to be put together and the queries to be handled in that manner. It cannot be called predefined, more of ad hoc in nature, and one should be prepared to answer them. Because of this, the relational databases have become all that popular, right. So, that is about the database organizations. Now, let us move on to something more fundamental, that is entity relationship diagramming. The entity relationship diagramming basically is a part of data description, right. So, one thing about the data description, as a very fundamental point you must understand right in the beginning, that the data models are abstract. There is a kind of data abstraction. See, it has basically two meaning. The meaning of abstraction is usually identifying the relevant portions of an object or an entity, right, choosing from several others, maybe attributes or properties, and using it for a specific purpose. This is the basically meaning of abstraction. But on a different level, the meaning of abstraction is the data description has little to do with the way a particular process is being carried out. See, I have given an example from bank. You might have seen many banks, could be the State Bank at IIT Kharagpur or maybe other foreign banks somewhere in a city. The operations of the banking will be entirely different, right. You may find more of manual processes here and more of automation in a foreign bank, right. The kind of things that we were discussing, like issues and receipts, the issues and receipts probably will be completely automated in an ATM counter. So, the data flows, or in particular the data flow diagrams could be organization specific. Please understand it carefully. Depending on which organization you are modeling, your DFD could be different. Is it all right? if you model a banking operation in here in Kharagpur, or you model it in another city, or you model in a foreign country, all your data flow diagrams will be different. On the other hand, for each of these banking operation, if the fields have the same meaning, the fields have different meaning, that is a different issue. But if the fields have the same meaning and you have the same number of fields, the database design should be exactly same. If you have more fields to consider, that is a separate issue. But if there are same fields, however differently they may be organized, the operations, right. The operations may be very differently organized, but if it is the same field, you have a customer, you have the customer name, you have the bank account, you have a transaction, you have an issue, you have a receipt, you have a ledger, the database design will be exactly same. Is it clear? That is why the data modeling compared to the data flow modeling is an abstract design. It is an abstract design. That is why it is called conceptual data modeling. It is a conceptual diagram, it has nothing to do with reality. As long as the fields are obtained, you get the answer. You need not understand how the fields are organized. Is it okay? So, in a way it is easy also, in a different sense. Why it is easy? You simply have to extract the fields and understand their meaning. You do not have to understand the context in which the people are using, whether it is a manual ledger or whether it is in floppy diskettes or who is using it. Some people may decide to put it in 10 ledgers. See, in a highly inefficient system, the same information may be in 10 ledgers, right. I have seen with my own eyes that suppose there is a government organization and by mistake you have written a letter to them. You have nothing to do with it. You just give them a letter that I do not know why you are treating me like this. I had some business with you, but you have not treated me well. Just give this letter. What will happen? Let me tell you. This letter will be first received in the receipt section. There is an receipt section. The receipt section, there is a incoming ledger. The incoming ledger, immediately there will be an entry, such and such letter has been received from such and such person. See, it is an elaborate design. Who has sent the letter, on which date, through which post office it has come. So, your letter is recorded. Now, after your letter is recorded, naturally the question is, since your letter is vague, to whom should it go, right? That requires certain decision. Naturally, the issue and dispatch clerk cannot make this decision. So, they will send the letter to another department, probably a little higher department, control department, to decide where these letters should be sent. Before the letter is being sent, there is an outgoing register. The outgoing register, again your letter will be entered there, and some clerk will come from the control section, peon. The peon will make an entry there, and again it will go to the control section. The control section again has an input register and an output register, alright. Then they will decide, okay, let us send this letter to Mr. X of some department. It will not go directly from the control department to Mr. X, it will come back to the dispatch section, obviously with 2 more entries, go to Mr. X, in this department one entry in the incoming register, then probably Mr. X will write, I have nothing to do with it. You will not be surprised if the letter comes back to you, we could not understand what is to be done about your request. That is okay, that is the end of it. But with nearly 64 entries in different registers of that company, it is a reality. I am not concocting this story. Exactly this happens. Exactly this happens. So, it is a highly inefficient way of managing data. Highly inefficient way of managing data. alright. But what I am basically trying to say, even if you go to this industry and collect the basic information, what is the basic information? A letter has come, is it alright? A letter has come. So, what is the information contained in the letter? One is who has sent it, on which date it has come, what is the post office through which it has been posted, to whom it is being addressed to, and probably any reference of this letter, whether he is a real customer or what is he, and maybe later on the content of the letter. Is it clear? So, even if it is an highly inefficient company, the example I gave, or highly efficient company, right, where the reception, whoever received the clerk, moment they see the letter, make a phone call that such a letter has come, please tell me what should I do with it. That is all, that is the end of it. A decision is taken then and there, and an answer is scripted to you. Alright. Even then, there, if they want to keep a record of this letter, the database content will be exactly the same. All you need to do, find the data fields, do the relational analysis through entity relationship diagramming, through normalization, and come up with the same conceptual data model. Alright. It is independent of the data process which is available there. So, there are data models do not relate to the flow of data, that is the key point. In fact, probably this is the reason why the object oriented analysis and design methods have become so popular. You see, since the data modeling or the database design is an abstract way of doing things and little to do with data processes, it has got lot of advantages. The advantages is that it can be reused, right. It is not dependent on the present situation. So, this is why whenever object oriented analysis is done, essentially it is, you can say it is an offshoot of the ER diagramming, an offshoot of database design, alright. But only thing, you do not call them entities, call them objects, and not only attributes, but you also associate methods, and definitely much more than this, definitely much more than this, but we shall come back to it in our next set of classes. Now, when we are describing data, there is essentially two levels, as I was saying. In the first level, we make a conceptual data model by using entity relationship diagramming, and the second level we carry out the normalization of the data elements. The normalized data model is then converted to a physical database. So, that is the basic process of data description. Let us look at what is an entity relationship diagram. The entity relationship diagram essentially has got three components, as the name suggests. The entity, look at in this small diagram, the student and the subject, these are the two entities, alright. So, between these two entities we have certain attributes. So, definition of entity, distinct things in an enterprise about which data is being collected. See, if you are not going to collect data about it, probably it is better not to call it an entity. A small example, students live in a hostel or a hall. Now, hall is an entity or not? Yes or no? Why depends? It is an entity, why not? Look at this, hostel is a distinct thing in an enterprise, yes or no? Definitely, alright. Now, the question is whether we are interested in collecting data about it. Suppose we are trying to also collect hall wise information, then we should not simply say the hostel the student is staying, we just do not put it an attribute, we also say student hostel, right, hostel, and between them we may have a relationship, fine, and therefore, student will have only hall number and the hall will have its own details, hall number, hall name, etc., etc. So, entity relationship, the relationship is the meaningful interaction between entities. Between the student and the subject, we have an entity, I mean not an entity, a relationship, we may call it takes, student takes subject, and I have, it is not shown here, but you can always show an entity called grade. Now tell me, suppose we do not want to include grade. If we do not want to include grade, is the relationship required? Understand the question. Suppose we do not want to keep grade in our database, right. So, there is no grade, grade is not given yet. So, do you still want the relationship table to be included?
Yes, sir.
It is required. The reason being, the which student has taken which subject, these questions can be answered. Now, attributes. Attributes are properties of entities and or relationships. What is the difference between property and attributes and entity? See, the student is an entity. This is a distinct thing. Anything that describes it is an attribute. So, do not confuse between attributes and entities. Please remember, the whenever later on we discuss about things like normalization and other kind of things, we must be very clear about an entity and its attributes. These are two different things. Otherwise, very common mistakes may come in. What is this M and N? See, I have written an M, I have written an N here. What are these?
Tuples.
Not tuples. These are called relationship cardinality. Relationship cardinality. Let me write about this. So, some examples. There are three kinds of relationship cardinality. 1 is to 1, 1 is to n, and m is to n. 1 is to 1, 1 is to n, and m is to n. So, 1 to 1, they are called 1 to 1, 1 to many, and many to many. Right, 1 to 1, 1 to many, and many to many. Say a many to many relationship such as student to subject. Suppose E5 is student, E6 is subject and ER3 is ST sub. So, what does it mean? One student can take many subjects, fine, true or false? True. One subject can be taken by many students, clear. So, this is why it is a many to many relationship. Okay. Think of the same example where there is only one subject. It could be peculiar, but suppose there is only one subject and there are many students, right, like in some ancient Indian universities, not really university, some very famous guru is teaching a single subject. Many students are coming to him and learning that subject. So, in this particular, in the context of this very limited scenario, we have one subject, I mean look at this way. So, this is student subject if it is there. So, one student can take I am sorry, this is subject, this is student. So, the subject is given to many students, but the student can take only one subject. So, that is called one to many relationship. Is it clear? One to many relationship. And in one to many relationship, we usually draw an arrow on the one side. See, this arrow does not mean it is flowing towards one or any such thing. This arrow has nothing to do with flow, right. So, it just is just a matter of indication to identify that this is the side of one. Is it clear? This arrow, one arrow you can see, this arrow simply denotes that this is the one side of the cardinality, relationship cardinality, one to many, clear. Now, one to one relationship, very difficult to obtain, because in real life there are hardly anything that is one to one, and if it is so much true to one, then probably you can merge them together. There is really no need to put it into so much elaborate structure. You can as well define them in one entity itself, alright, very difficult. Suppose in an institute you have just one student and there is only one subject, and this situation will never change. Then you can say it is an one to one relationship, right. Suppose you have separate records for a particular chair professor, there are some foreign universities, they call some chair professors. So, the chair professor and the professor, right, only one professor can become that chair professor, and in that chair professor at a time only one professor can be there. This is a kind of one to one relationship. So, one to one relationships are basically no point in discussing much, it is a theoretical possibility. In all practical situations, one to one is almost ruled out, does not really there. A very peculiar thing about one to many relationship, not always, but many time whenever you have an one to many relationship, first of all let us see many to many. See, in a many to many relationship, I was trying to show you, suppose there are 50 students and there are 10 subjects. So, theoretically how many combinations are possible? 500. So, you can see that in a many to many relationship, the relationship tables are usually larger than from both the sides. Is it okay? But a peculiar thing about one to many, say an order and supplier. how many a supplier, how many orders can be given? One or more. A given supplier over period can have many orders, yes or no, right. But can a supplier, can a given order be given to more than one supplier? Sometimes yes, in peculiar cases yes, sometimes an order is shared between two suppliers, very peculiar cases are there, but in most 99% of the situations or in 99% of the organizations it is not the situation. For example, IIT Kharagpur more or less gives orders to single suppliers. So, a supplier can have many orders, whereas an order can have only one supplier. So, which is order, which is supplier, you tell me. This is order or this is supplier? This is? This should be supplier. Why? See, a supplier can have many orders, an order can have only one supplier. Fine. So, these are some examples of one to many, but let us say there are say 5 suppliers. There are 5 suppliers, okay, and there are 50 orders. So, how many will be there in R2? It will be 50. Anybody having any doubt? You try to understand. There are 5 suppliers, alright, and there are 50 orders, alright. So, these 50 orders, now if you try to combine them, but the combination will be always 1 to 1 because a given order will be associated with a single supplier only, is it not? A given order cannot be associated with all 5. If a given order can be associated with all 5, you would have had 250. But since a given order has a single supplier, there will be exactly 50 in the relationship. Now, a very peculiar thing has happened. You have 50 here, you have 50 here. So, what is possible? And one to many relationship, suppose we have an order file, we have an supplier file, and we have an order supplier file. We can replace it by only the order supplier file and the supplier file. We need not have a separate order file. Can you see this? Please understand it very carefully. It is an one to many relationship. Since the number of records here is 50, number of records 50 here, it is exactly going to be the same, alright. So, instead of keeping 3 records, 3 separate tables, we can keep a supplier table, we can keep an order supplier table, or in other words, in the order file itself, we can add the supplier number. Instead of separately keeping order and supplier in a relationship table, see, we are calling it order supplier, but it is nothing but the order table only. So, we have the supplier table, and in the order table, we also keep the supplier information. So, in essence, what was being done by 3 tables could be possible to do in 2 tables, but it is not a rule. Exceptions do exist. Exceptions do exist. There are situations where these generalization may not be possible, but you can save. Please understand, more number of tables you are defining, more joins you have to do, and more joins means more less will be the response time. The response to the queries or the database processing time will be that much higher. So, one need to keep this in mind and do things accordingly. Okay. So, let us close it here, because anyway we have been delayed today. Continue from here next class.